in the way that we want our master's students to go, we always want them to do a business case. And the ideal state in which each and every student that comes through the work that we do, the idea is that we make sure that they have a master's, but they also have registered an enterprise that can provide a product or provide a service. So, you know, when they ask you back there at the factory, what is the Gibela Research Shed doing? Tell them that it's producing postgraduates, doctorates and masters and postdoctoral fellows, but also entrepreneurs. Because that dimension, many people miss it because they think, it's the run of the mill. But there's something important that we're trying to do here, you know, creating these entrepreneurs. So hopefully, Skosana's work is going to give you a window into the kind of mindset that we're trying to build. So you will see that his approaches in terms of the technical work that he's been doing on the research and the business aspects is something that he always engages on. So with those words, Kosana, is your PowerPoint working with you? You didn't wash at the right river. I see there are many rivers here. Which river did you go to, Kosana? You don't have a PDF version? Why don't you try the PDF version? Yes. Over to you, Madam Peme. Please pray for Skosana. It looks like technology is not working with him today. And then in the meantime, we'll give the opportunity to the next person.
It works. Okay. Before you start, Kosana, does somebody own a white Huawei that's apparently lost? Did any one of us lose a phone? Hey. Okay. I'll wait for it to ring. So, Kosana, we are giving you maximum 15 minutes to give us all the details regarding your study. You can start when you're ready. Oh, you have a mic. You don't have a mic. A mic, please. Take it, try it. But there is a mic.
Good afternoon, everyone. My name is Kolani. So today I'll be presenting a master's study which started in 2019. So besides the learning of the subject matter, which is what I'll be presenting now, VR, I've seen that master's is a study of self. because through the journey, I've come to know more about myself than about VR. Although today I'm supposed to be technical and present on VR, but you will pick that there are certain things about me which are in development. So the study is based in the Railcar Learning Factory. So when we are talking about bridging the gap between industry and academia, we need a place for this to happen, and that place is the Learning Factory. So we have one which is based in Hatfield. We call it, it's the Zila place. So there's the physical aspect, and then there's a virtual aspect. The physical aspect of it is everything that is happening in a manufacturing factory or a mining setup should be replicated in this learning factory. So that's why we have 3D printers there to print scale models so you can represent an actual train. But then there's also a virtual aspect, which is what I'm presenting on, that everything should have its digital counterpart. So my problem is very simple. Like the goal is to reduce the time that is spent on physical training. And to do that, it means that the worker should do less errors, because the reason why a person goes through training is so that they have less errors. Soon as they do less errors during the assembly task, then they are competent, they are ready to do the job. So the goal then is to reduce the time that is spent on physical training. The solution we are proposing is virtual reality. And we are saying virtual reality can reduce the assembly time, the time spent on physical training. Although that is true, we need to study this on different contexts. There are people who have done it. I'll present what they have done. So the solution, as you can see here, you have like a person who is wearing the headset, and then they are performing an assembly task. They're interacting with a software, which is what the company is doing. The company specializes in developing software. The company didn't exist before this master's study. So I needed this program because I had proposed it, but then I didn't have the capacity to build it. So then we outsourced. But then after that, why I say it's the development of self, we went through a practice where now we had to recruit people to develop our own application. And that became a whole exercise which I think made me a better person, more confident in what I'm doing, and etc. So the aim was to develop a framework to guide learning factories to say how can they conduct virtual assembly training. So everything that I went through, the point of the study is that everything that I went through, if I give it to someone, they should execute it. So this will be done by firstly identifying how to determine what is effective virtual assembly training. And then after that, the requirements of like virtual assembly training, they evolve over time. Like you start by being not so specific, and then as the process goes, using Agile, it becomes more specific, because you don't want to define everything, and then, because once you start development, you see that there are many changes. So that's why we chose to go for an Agile methodology. And then once we were done now developing the system, we then evaluated how usable is this system using two methods. A cognitive walkthrough, I'll explain it later because I want to get to the framework, which is the most important thing. And then that's it. 4 objectives. The final one is the framework where I want to spend most of my time. So we then looked at literature, downloaded a whole lot of papers, 129, and then developed an inclusion and exclusion criteria focusing on primary studies. We wanted people who did the same thing and reported, people who invited real users to use the system which they have developed. So that exercise was done, and then 57 papers were selected. So far, hey, I've only managed to review 10. I'm not sure if I will continue reviewing the rest, but then I think Mr. Watunde yesterday was saying, if you don't put a full stop on a study, no one will put the full stop for you. So I've reached a point where I think this is my full stop. So from the findings, like we identified three most important things. Like it's the user, the software which you are building, and then the hardware. And then there are points that interlink in this thing. Like what is most important is that the user comes to you with requirements. I noted what was said when I was saying like selling to the university. And the panel discussion, what we had, the take home there was, stop pushing things to industry. Let them pull things from you. And that means you need to cover their requirements. So they have requirements, and then their requirements, whether or not they were met in terms of training, is measured through what we call training transfer to see how much of what was learned is actually being applied when they are now in the workstation. And then in looking at that, there's an interlink with the hardware then, because I'm just presenting about VR. Later on, you will see how my colleagues are advancing this study in Mutari. So there's a lot we can do, but then I'm just focusing on VR. So there are other alternative training methods which I'll just like browse through them. And then the hardware itself, you have an input device and an output device. What you are seeing now, it's an output device. A monitor, it's an output device. And then the input device, how you bring, feedback to the system, like a keyboard, a mouse, that can be an example of an input device. And then where it interlinks with the software is that it has a feedback mechanism. I think I don't want to jinx it for Mutari, but there are many feedback mechanisms you can use. You can, like, we can get to a point where now you're saying you want the person to say, pick part 1, and then the action happens using voice command. So the feedback mechanisms. And then the usability of the system. The usability of the system, the VR at this point, it's even though it has advanced really in terms of research, but there are still concerns about how it brings about motion sickness after long exposure. So if you are immersed for longer than 30 minutes, you could get sick. So those are some of the things we still need to deal with. From a usability point of view, we ensure that our application does not have that through a cognitive walkthrough where with a colleague, he gets immersed, and then we look for particular errors. So where everything interlinks in terms of autonomy and adaptability, there's this, when we're talking about VR, we are not saying do away with physical training. We are saying that it can supplement or complement your existing method of training. But then now from an investment point of view, it becomes a bit interesting to say, now you're saying I should buy these things worth $500,000 or so, and then on top of that I should get someone to facilitate the learning that is happening virtually. So that's why there's this urge to make these systems autonomous. So they should be able to they should be used without the human being there. So, okay, I can go deep, but then no, let me jump. So from the literature review, we identified a lot of things, like there are different training methods that are used, there are many evaluation techniques. We focused on looking at the assembly time. But then apart from assembly time, we could have given our participants questionnaires, we could have monitored the errors that they were doing, and then we could have sat down with them through an interview. And then the studies differ in terms of sample size. We had a sample size of 55. Studies range around 25. There you'll see there in this literature review of the small number of papers that I've reviewed here, you can see if we are just focusing on sample size, you have like, you see now this data will take my time. The point there is they are ranging, like you have some studies who are doing less than 15 who have less than 15 participants, and there's only one who had more than 60 participants. And then how you analyze this data using one-way ANOVA, two-sample, because I think this question might come later on to say, how did I analyze my data, and why did I choose one-way ANOVA and t-test? I chose it because people in the same space are using it. And then ultimately, how effective is VR? We have studies there, 2 studies who were in favor of VR to say it's really effective, and then some found that it's comparable to your normal way of training. And then there are different products that you can choose to do your virtual assembly system on. Ours was a railcar component called the top bracket, which is assembled using the welding jig. Okay, I want to get to the gist of it, sorry. So we went through the whole process of developing with our developers, Mutari, now Modiba, who left. We went through the whole process of looking at the task and then defining the task in detail, documenting the requirements, doing a system architecture, and then building the system using SolidWorks and the others, and then coding the actions using Unity, all that, which is what I've explained, right? And then ultimately, we then, if you're really interested in this, you can just look for this paper here, Skosana XNia. It's there, it's reporting on the development procedure that we undertook. So the study itself, what happened is, I had aimed for 38 students, but then I ended up getting more than what I had intended. So we got like over 100 students, but they didn't come on one day, in 3 days. So when they came, we briefed them on the experiment, and then we got their consent. And then we divided them into 3 groups. One group had an instructor, which was a person showing them how to do the assembly. And then 2 groups were using the virtual assembly system. But now, the difference here was one room had no audience, and then the other room had an audience, because we wanted to see the impact of an audience on the learner's performance. And then after taking them through these 3 modes of training, we then gave them 3D printed parts for them to do the assembly, which was mimicking the real component, but then now it's 3D printed because we couldn't get the jig. So here you can see we're briefing the students, here the instructor explaining the task, how it's done, and myself here and Giovanni immersing this learner, and then Mutari here being a facilitator in one of the rooms where there was no audience. And so we formulated 7 hypotheses, right? And the first 2 were trying to compare generally, like if we train a person using one of the 3 training methods, how will they perform in the physical assembly? The first 2 hypotheses look at that. And then the 3rd and 4th hypothesis, they were looking at between the group with no audience and the group with audience, how are they performing in terms of virtual assembly time, right? And then the hypothesis number 5, okay, so this will confuse me, but so the findings was that represented visually was that there was no significant difference. It means it's comparable to, VR is comparable to instructor-based training. What we found a significant difference in was the training with an audience being in the room. So that is key. In a previous, there's a study that was done by another scholar who said that people being in a room, they distract the person who's immersed, and that is bad for the learning. But in our own finding, we found that the environment with an audience is more conducive to learning. Because then when the person is immersed, they are doing mistakes, and then the audience is like assisting the immersed person through, so they get to learn from other people's mistakes, and then when it's their turn, they spend less time there. But what this is saying is, like, we got them to assemble the 3D printed top bracket 4 times, and this is what we found. By just judging visually, you can say that those with no VR without an audience, they performed faster. You can say so. But then when we subjected our findings to an analysis of variance, we saw that there is not really a significant difference that was picked up here, making it comparable to your conventional way of training. So here then we are comparing, like, between the learning, looking at the virtual task itself, the learning and the assessment mode. Is there any improvement? You can see, as they use this device, during the learning mode, they don't know anything about it, they use the device, their time improves. But what we found here was that those with no audience, they're spending a lot of time here. Their time is way high. And that's the only part where we found a significant difference. So I think it's what I've said, but then hypothesis 7 or 6, if I'm not mistaken, that's where it came in to say, but then there are some where you have an instructor and the instructor is showing the person how to do the task. And then you have those ones who are being trained virtually and now they are doing it virtually. These guys, they were just shown how to do the task, and then now you're giving them the real task. So you're saying they should learn from observing, not really from doing, which makes the whole comparison unfair, because the other guys, they are doing, but they are doing virtually. So then we tweaked around to consider, to say, let's say those who are doing instructor-based training, let's say the first assembly was the training, and let's not regard it. And then let's go to the second assembly to make it comparable now. And then even there, we found that there's not much of a significant difference. So it's not about to say, but this ones, they just observed, they didn't do the task. No, it's not about that. They did the task. When you look at those who did the task and those who did not do the task, the point is, it's the same. So then, where I wanted to spend most of my time, is the human-centered system design. So once we agree that we are designing a system for training, we can agree on the methodology that is appropriate to develop, and that it must be human-centered. So that is the basis of this. And then now, what we've been talking about now, about the solution being pulled, not pushed, this is what we did wrong. And that's why I'm not confident to speak about the continuity of what we have done now. Because currently, okay, we did it, it's for training on welding jigs, then what? Who's using it? So the process of market validation is very key, because in this process you ask, who will pay? You can have a person come with a nice idea and say, yeah, why don't you do this, but are they willing to pay for that thing? So market validation, we just skipped it because I guess this discussion was not there. But we need industry to be the one who says, training is a problem, but where? Because there's so much we can train on, but where do we start? Because that speaks to demand. And then, for how long are they going to pay? And those people we are approaching, are they willing to share IP? Because now, this is a very key one. You know, it's light, but it sounds light, you know, to say how much are they going to pay, with who are you going to pay this with. But if it's an enterprise software, then it's your IP. You would want us to develop the solution, and then you own the solution. But then now, if you are the only one who is using that solution, and you are willing to pay millions for it, then it's fine. But then now, if you ask for a cost, we give you millions. it's because you are paying for the time we are spending developing that. But then we are trying to move away from that to create something that we wouldn't have one person paying for it. But then that now speaks to IP issues. To say if we have just a training on a simple how to assemble a car, and then you can have training providers subscribe to that platform so that when they ask for cost, you just say it's 550 per learner. Then it sounds less intimidating than when you say, how much is it, and then I'm going to count the man hours to develop it. So you should not pay for development. That's the point. So there were no people. People had to be there, and you find that the people, you know, they are not robots. You can't just move them around. You have to manage their talent. You have to, since this is in R&D, even though you want them to do a certain task, you don't want them to be boxed and just do what you are saying they should do. You want them to do other things which could add value, maybe in a long term or so, because that's the nature of it. It's fast evolving. So you are managing the talent. So, and then after that, you then create your assets and scripts to guide the development, and then you build the environment. And then the other one, it's skills, knowledge, and technology transfer, which is what I spoke about, to say, once you have the headsets, you should make a decision now. Like, for instance, a model that we are proposing is that who owns the hardware equipment, because the equipment itself is expensive. So whoever owns that equipment can, like for instance now, let's say an example, TUT owning the headset, the VR equipment that it has. Again, the entrepreneurial part that no one will teach you, which is what you find for yourself. No one cares what you want. Everyone cares about what they want. So until you can talk to what they want, you will not get any joy from them. So looking at what universities now want is a third stream of income. That's what universities now are looking at. So now it's about saying, since you have this infrastructure, how if you open up how if you give other stakeholders who don't have buying power for this thing access, so that they just subscribe to use the software, but then they pay you for using your hardware. I'm summarizing. And then the usability studies, which is what I spoke about, to say which is what is key before launching the system full on. And then once you've launched the system full on, now developers should upgrade the system, spending time on upgrades, and then also it's the studies that come after this. It's not just about deploying a solution and then looking away. Once you've deployed that solution, it's about seeing all the requirements that they said they have, how much they want to reduce training and so forth. Have we met that? Is this solution really meeting that? So that we can tweak it where it's not meeting the customer needs. Thank you.
Yeah, I think with this member, you know, you just need to observe the energy around this whole thing. And you are left with only one option, maybe to give another round of applause. You can see that the member didn't study this thing with his head only. You know, he studied with his feet, with his, even when you talk, see, make sure that you see it, that this thing, I was visual realitying it, you know. So well done on that, Kosana. Yeah, even the judge there shaked it a bit. So at this juncture, we need to open up for questions. You've taken a bit long, but I think there's a conversation to be had here. So let's see those who have got questions, points of clarity. Like we said, he's doing this for his colloquium, so this implies that, you know, this is the last time maybe he's speaking about this. And the next step maybe will be, it must go to assessors if the DCRI is happy with what has happened. So from here, all the people that we've said are doing colloquium, just for the sake of everybody, all this will go, and the clips that are associated with whatever they were doing here will go to the DCRI, and then at the DCRI, a decision will be made there whether they must go for assessment or they must go back to the lab and do some more work, just for clarity for everybody. But for us here, I think the purpose is for the panel to get a sense of where exactly they are with their innovation. And I saw a hand from Gaugelo. Is there another hand, or it's only Mamazala? Yes, I see Dr. Oyesola, Dr. Oyesola, and then we'll end with the industry. We'll give the industry the... Mamazala, you can go.
Why Mama Zala? Prof, you don't have to say this. He's actually my son-in-law, so yeah.
You are conflicted, madam, so we must declare your interest here.
Yeah, no, I have to. No, I'm joking, not really son-in-law, yeah. You know, when you study with the youngsters, they will give you all the names. So, you know, so Kenna Mama Zala. But anyway, with the literature review, is it possible just to quickly probably go to that slide so that I understand? Because I saw that you only have 10. So, Mina, in my mind, I'm thinking, okay, the entire thesis only has got 10. I mean, yeah. So I think that's my question then, eh?
Dr. Oyesola, are you next? Mamazala is done.
Okay, so I must first commend Mr. Kusana for the effort, the zeal and passion you have put into this research work. It's what's commendable. I would like to know, what caught my attention has to do with the ANOVA, the analysis of variance. So what are the technical standards you compare that with, so that to validate the result? You compare the result with, like, on what basis do you compare the result with?
What did I compare this result
With, to ascertain how valid the results are.
Doctor, you have some insights which I'm unclear about how to do that, because I got primary data, then I got the data, I put it on Origin Pro for it to calculate this analysis of variance. My interest was the mean and so forth. And then once I got that data, I just made the interpretation. Oh, sorry. I just made the interpretation. So I wasn't aware that I should compare my primary data with anything. What's there to compare it with?
Yeah, when it comes to statistical analysis, there are some some points you have to check that serve as the benchmarking element for you to say, oh, this result is valid based on this 1, 2, 3 element. That's really why we could arrive at this and say our result is perfect.
Okay. So I'm sitting in the right place next to you there. You'll help me with
Thank you very much. That one goes forward. And then we go to Lufun Luvuyo.
Hello. Yeah, so I think, thank you for the presentation. It is very exciting technology, especially in the age we're living in. So I think I have 3 questions that I've noted down. So because now I think the new buzz is towards the metaverse. So the question that I want to ask is there a planned integration as you are moving forward with your studies to say, but in the end, since the metaverse will become more prominent, more out there, this is how we will integrate these virtual reality training spaces into the metaverse. And then I think the second question is, because with the virtual reality, it's not coding, it's more modeling. So, and my colleague Tabiso and Ezra mentioned, we always need to mention as Gibela the 6 trains and the fact that it's not only Gibela, but it's the suppliers as well. So how fast can you accelerate to say, when industry says, this is what we need training on, this is who will pay, this is when we will train, and this is the station we need training on. How fast can the development happen to say, once the need is identified, we can, in X amount of time, deliver the solution to industry so that we don't end up doing the face-to-face and then VR, So how fast is the development? And then I think this one is not only for you, and maybe Prof can help us with this one, is for me, I think when I saw Mr. Skosana's energy and drive and enthusiasm on this topic, my question is always, how then do you accommodate research and hypothesis bias? To say, I'm very excited and I know this concept can work, but do you actually do literature review of things that disprove that this solution can work? Because, you're so excited and you're enthused, but where's the literature review that says, no, actually, face-to-face training is better than virtual reality?
Fantastic. Thank you very much. I think those are very valid questions. I see Ntate Komako.
Okay. Thank you, leadership, for this submission. Yeah, it's quite interesting. So I just have a question, especially when it comes to your hypothesis. I firstly acknowledge the fact that obviously towards the end of your presentation, you did identify gaps that we probably need to improve on in terms of market analysis and so on and so forth. But don't you think, if I'm sitting here and I'm the potential customer, wouldn't I, because I'm running a business, wouldn't I need to get comfort, in terms of, did you test the ability for a learner to produce quality, number one? Secondly, you did indicate, if I'm correct, that looking at your first and second sample, you did not see any significant difference in terms of, let's call it cycle time, whatever you may call. But I'm more interested in the product, to say the output. Wouldn't it be more valuable to also extend, your hypothesis to cover what matters in business, which is delivery, quality, and safety, for an example, EHS, the exposure of the human factor, into risks associated to health and safety. Thank you.
Thank you very much. Skosana, in that order, I must say to Luvuyo that, the energy, is from the money that can come from this. So it's not about literature, this thing. So but Skosana will answer for himself. But the way I have, when I've studied the colleague, the idea that I picked up, the energy is about the money. There's literature review, but the money is more interesting. So, but he must answer for himself. He's an old man.
Yeah, I think the pending question is about literature review, because I understand I might take this personal because it's my business, and then as Prof is saying, there's money as a motivator, so I might want to just sell it and push it to you and say it's effective without gaining substance on whether this is effective. So, to answer also Mamazan, the systematic literature review was only on, what I presented, only on the 10 articles. But during the course of the study, I didn't study 10 articles. There's a lot that I studied. It's just, it forms part of the literature review, which is part of the study, not the systematic literature review. Because I had my own plans, which was to continue this literature review, and then in the end, be able, when I come to you, really be the one who says that so many companies located where have found this effective compared to what. That's what I would have liked, because right now I'm only quoting you, for you, 3 studies that suggested that VR is effective, and that's not enough. We can do better, we can do more, we can get you more proof. But we are not saying it's only, in all cases it's effective. There are some cases that show that it's not effective. And we need to continue the systematic, the literature review so we can get more of this concrete data. And it touches on the last point then to say, but
1 minute.
But the learner quality, looking at can this tool help the learner produce better quality on site? And that needs a study to be conducted on the job. And now that's a different methodology than the one I used. The one I used, design science research, is just focused on the lab, to say we want to get a proof of concept for the lab. But then the next level where I'm saying someone else now should continue the study would be now taking it to the site and then doing all those studies to say how is it transferring in terms of quality. And then the time to market, which is a very key one, like how fast can we do it? And we made the distinction, Luvuyo, between modeling and coding. And most of the time we spend on modeling, right? And then after modeling, if we have the models and they are ready, if we have dealt with the IP issue and the models can simply be released, then the time to market is shorter. But then still, I'd be thumb-sucking if I just give you an amount, like to say it would take a month. We need to see how complex is that operation and how much in depth do you want to go in this thing. Because you can just have a case where you are saying the person is assembling a table, they're taking this and they're taking a top and all the components and bringing them together, and you're not being detailed about which tool are they using, how should they turn the screwdriver. The more detail you want to cover, the longer the development will take. But then if
Thank you very much, Kosana. Unfortunately, you are appetizing and all these things, but maybe the discussion must continue offline. But I think all of us have a sense that the young man is passionate about the technology. He just needs to be directed to the right area. I will ask Musikwa to come and set up while Kosana is going to sit down. But thank you so much, Kosana. Maybe another round of applause. Even the manner of the answering of the questions, you know, you can see that this thing, the young man is on it. So well done on that, Kosana. That's the passion that we need to display. I must say that from day one, Kosana has been funded by Gibela. So, you know, there is value for the investment that Gibela is making. Please do report to the other colleagues who don't have visibility. I hope some of you took a video that look at what the investment is doing. Wonders here in Malda's Drift. Where is the comrade? Yeah, please set up. Are you not setting up? I don't see the laptop. Oh, it will be projected from that side. Okay. So thank you very much, Musikwa. I'm not seeing the projection. While the projection is coming, I'm reliably informed that there are things that I need to hand over. If maybe Prof. Munda, we can do that so that if the colleagues need to find their way out, then we have done the needful. Khumuto? Is Khumuto, where is Khumuto? Tato, can you please assist? Oh, okay, I see.
And I'm also not expecting to say something much. Just on behalf of TUT and the chair, to really, really appreciate the time and the effort. We don't take it for granted for the executives to have found time to be with us today, the whole day. It's not always the case that you've got a project where the partner then delegates a whole team to you for 3 days and executives for a whole day. So thank you very much, and we look forward to many, many more engagements with you. Thank you.
Good afternoon. My name is Mosekwa Mufepa, and I'm a DEng candidate, a Doctor in Engineering candidate in Department of Chemical, Metallurgy, and Materials Engineering. So I changed the name, yeah, in Polymer Division, under the supervision of Prof. Caroline Kwatane and Drs. Ojijo and Dr. Mulna. So the title of my poster presentation, it is a poster presentation, it's the development of fiber-reinforced polymer composite filaments for additive manufacturing in the transport industry. Additive manufacturing is a class of manufacturing methods whereby the material is layered, a layer on top of another layer, forming that part. For an example, it could be this projector. It could be this projector being manufactured from the bottom up. That's how the additive manufacturing process works. And this part will be from the CAD model. So a CAD model, it's first modeled in the computer, then transferred to this additive manufacturing processes. And the types of additive manufacturing processes, we have the one that uses powder, which is called the laser sintering, selective laser sintering. It uses powder materials. We've got the one that uses the liquid polymers. Most is the liquid resin, which is called the stereolithography. And then we have the one that I will be presenting on, which is the FDM. FDM actually is a trade name, and it is now called FFF, which is fused filament fabrication. Then this is the one that I will be presenting on. So the aims, the challenges of the FFF additive manufacturing technique that I'll be using is that This technique only uses thermoplastic polymers. So that is one of the challenges. And then it doesn't print large articles. It can only print the smaller parts and not the bigger parts. For an example, cannot print your door, the length of the door, if that can be a product. And then the aims and the objectives of my research as projected is to develop a carbon fiber reinforced polymer composite using extrusion molding, and then do the performance evaluation. This performance evaluation will be your mechanical, your physical, and your thermodynamics. The objectives being is to determine the better process parameters for filament extrusion and to characterize that filament that is extruded for the application in the transport industry. So, firstly, I started with evaluating the raw materials. I can see it's not very visible from the projection, but it's written raw material evaluation. And the raw materials that were evaluated is the polymer matrix. The polymer matrix that was used is the polypropylene, and the reinforcement being the carbon fiber. The carbon fiber was bought from AMT. AMT is a composite supplier, and it was bought in a form of a twill. So it's like your hair strand, but in a continuous form. So I had to cut those carbon fibers in a length of 150 millimeters so that I can be able to extrude it. And then I compounded that carbon fiber in that required length together with the polypropylene, and then characterize. I can see it's not very visible. It is compounding, characterization, then filament extrusion. From there, this was tested to enable me to see if the filament that I've extruded is of the required properties. For example, during extrusion of the filament, of the composite filament, I noticed that the diameter is not what I expected, because most triple F printers, which I will say FDM 3D printer, most of them uses a thickness of 1.75 millimeter of the filament material. So I noticed that I was not getting the thickness that the 3D printer, which is the triple F, required. And the other thing that I noticed during compounding is that the fiber distribution during compounding was not consistent. So some parts will be with higher fiber content, and the other parts will be with higher polymer content. So I had to re-extrude. Before re-extrusion, I had to put that filament through the granulator, so to make granules, because it's a long strand from compounding in the extruder. Then I had to put it through the granulator to make the small granules, that is like your pellets. And then from there, the next step will be to re-extrude and to put it through the 3D printer, which is the fused filament fabrication. That part is in the purple. If you can see from the figure one, the process flow chart. The purple, that is when I will be using the 3D printer, which is the FDM. I haven't done that section. So what I was explaining to you, it is the process flow, which included the methodology on how I went about processing or compounding my filaments. So going forward to the figure 2, which is the research design and methodology, I can see from your side, I'm sure it won't be that much visible, but then at the bottom part, on top of the figure 2, I have the properties of the carbon fiber. This carbon fiber that I acquired from AMT Composites, it's in 96% of the carbon content. So it's very high in my carbon fibers. And the rest of the 4% will be graphene content and the other small additives. And in that properties of carbon fiber, there is also the tensile strength, which is up to 5,500. So the strength of carbon fiber, that is why I selected the carbon fiber to be my reinforcement, is because the strength is very high. So the parts that will be produced from carbon fiber are very durable. And carbon fiber, it's low in density, which means the particles will be lightweight. And if it's automotive parts, the parts will result in that automotive vehicle to be low in weight, and overall reduce the fuel consumption. And then the next picture, which is also at the top of the figure 2, second, the bottom second, it's that is the 3D printer that I'm going to use. Maybe I can try to zoom on this. Oh, I don't know what I did. That's the one. So how do I take it back? Okay, thank you, Program Director. So the picture at the bottom, this is the 3D printer, which is called the fused filament deposition that I will use. So at the top, where you see there is a line, it's in semicircular, that will be the filament that I would have compounded on the extruder. So at the, okay, standing here, it's the left, that is in a circle, which is in black color. That is the filament that I'm going to use to print on the printer right on its right. So the filament that I've produced now, it's the first trial, so I need to granulate this one and re-extrude so that I get the required properties and the thickness to run on the printer. Okay, so moving forward to the results, I think I've touched on the results as well when I said I did not get the required properties that I wanted, so I will have to re-extrude. And the reason that the carbon fiber was made to a length of 150 millimeters, I think I mentioned this before, it's because when I extrude with the carbon fiber lose its length during extrusion. So the second extrusion as well will reduce the carbon fiber length even more. So after that, I will go and run the TGA thermography metric analyzer. Then I will check the carbon fiber content, because this carbon fiber content, if it's high, then the properties as well will be high. So I still want to maintain that high fiber content in these filaments. And going to the incubation and business case, the financial benefits of this whole project is that when the pandemic hit, the COVID-19 pandemic hit, that was 2 years ago, many importers in South Africa were importing these filaments for their 3D printing manufacturing. They could not do that because all the borders were closed. And then other companies here in South Africa, like the one that I'm in touch with, which is called SA Filaments, they started producing their own filaments. However, now we are in close contact because they are also interested in manufacturing filaments that are reinforced with the fibers, because at the moment they are producing fibers that are made of only pure polymers, like your PLA, and all sorts. And the technical benefits is that the additive manufacturing actually was used for prototyping. However, now with this study, the filaments that we'll produce, as well as the parts, will have improved performance and cost reduction, as well as the quality of the parts will be enhanced. So I would like to acknowledge TUT, the Polymer Department, Gibela Chair, and the CSIR. Thank you.
Thank you so much, Ms. Mufeba, for that lovely presentation. Now I think we know more about additive manufacturing, but I know we've got doctors who worked so much, who researched a lot about it, so I don't know, you see, hands are up already. We are going to allow questions. We are just gonna have maybe 3 minutes for the questions and the comment. Let's keep them brief. Datesak, let's start with you. And then we go to Dr. Danny Young. Mabalani, you know her, you will talk to her offline. And then Dr. Mubunzi. I know she asked you questions in the morning, so we don't retaliate.
Can I?
Go ahead.
Afternoon, ma'am. Just a simple question. How are you going to keep the cost down? Because resin, honestly speaking, it's very expensive.
Let's take Dr. Danny Young's question and then you can respond.
Thank you so much, Ms. Musikwa, for that well-articulated presentation. Just a few comments, then I think I have 2 questions for you. The first comment is that if I'm the one doing this work, I will definitely change the title of the work, because I perceive that there is tautology in the title of the work. The work reads Development of Fiber Reinforced Polymer Composite Filament. So the word fiber reinforced already stands for filament. And you cannot, bring composite again after you have talked about the fiber reinforced polymer. So if I'm the one doing this work, I would rather go for development of carbon fiber reinforced polymer for additive manufacturing. So that is what I will go for. That's the first observation there. Then the second one is that you mentioned that you were not getting the desired results, and I perceive that one of the reasons for that is that you did not apply the principles of design of experiment techniques. If you have used it, probably it will have given you feasible combination of the range of process parameters that can drive the experiment in the forward direction. So I will advise you to go for maybe Taguchi or response office methodology in that regard. So with that, you'll be able to get at least the ratio of the reinforcement, the polymer matrix, and the weight of the composition. So to my question, so how do you fix the range of the extrusion temperature and pressure specifically? What's the range of your extrusion temperature and pressure? Then I discovered that you use the PP-based carbon fiber. We have other types like the PAN, which are application specific. So what informs that choice of PP-based carbon fiber? Thank you.
Thank you very much. Mr. Saka, with the cost of carbon fiber, you are right. Carbon fiber is very expensive because I bought 200 gram for about 230 rand. So it is very expensive. However, my colleague, Mr. Mabalane, is working on the recovery of recycled carbon fiber. So this research, at the moment, because I'm starting the research, I'm using the store-bought carbon fiber. However, when the research goes further, we will incorporate the recycled carbon fiber that Mr. Mbalane is working on. Thank you very much. Dr. Daniel, thank you for the comments. Thank you very much. I'll take that into account, especially the design of experiments. I'm in talk with someone who will assist me with that, so thank you very much. And as well, I will come to you. I know you've got much experience. And you asked about why polypropylene and not other polymers. For research purposes, because polypropylene is widely available and not expensive, so I decided to go with it. And on literature, I've realized that other researchers have said that polypropylene does not print well because it does not adhere to the print bed. So I want to see those challenges and try fix them. That is why I went for the polypropylene. And as for the temperature that I am using to compound, I've used temperatures 180 to 200. These are the polypropylene temperatures so that I don't degrade my polypropylene because I will do a double extrusion. Thank you.
Let's get a question from Dr. Muvunzi.
I want to start by thanking Musikwa for the good work that she's doing. This is really a good application considering the benefits in terms of lightweighting and especially for the automotive industry. So mine is just a contribution that I've noticed that you want to apply this for, is it for the automotive or?
At the present moment, it's for automotive.
Okay, do you have specific parts or that you will in the end build as your case study?
Okay, on the interior part, there's the console. That's the parts that I'm going for.
Okay. The reason why I'm saying that is that there's a huge appetite for, especially in the area of electric vehicles, because that is where things are going. And one of the major drawbacks when it comes to electric vehicles is the issue of weight, which impacts on the performance of the vehicle itself. So I was just thinking that maybe it would actually add more weight if you maybe consider a case along the line of electric vehicles, because it actually matches on the reduction of weight. Thank you.
Thank you, Dr. Muvunzi. I've noted that. Thank you very much.
Thank you very much. It looks like we don't have further comments. With that, we can move straight to the next presentation by Mikateko Nomneba Baloi. Mika, you have presented a similar study before, so I expect you to be brief. I'll be happy if you cannot exceed 10 minutes. I'll be very excited. I can forgive you, but I don't know about the judges, so it's up to you. When you're ready, go ahead.
Good afternoon, ladies and gentlemen, all protocol observed, and we thank you once again for your time and availing yourself. So basically, my study is based on the development of cloud manufacturing implementation for SMMEs, a case in South Africa. So what you see in front of you now, it's just a presentation layout, how I'll be going through it. I won't dwell too much on other things, but we'll surely touch something. So we can have background or introduction. We have seen the transition of the manufacturing space, how in the 1900s it was just an assembly line focusing on certain aspects. And then we moved along and say, hey, Toyota was like, no, let's reduce the waste and overproduction and let's introduce continuous improvement. Furthermore, in the 1980s, there was an introduction of flexible manufacturing systems where their focus was more on the reduction of innovation and improving productivity. In the 1980s, someone is like, I'm better than that. And they go and they look into the reconfiguration of manufacturing systems, where it was more onto rapid upgrading of and quick interjection and exchanging of new technologies. 2010 and beyond. Our cloud, well, a simple thing for cloud, it's internet. So there was an introduction of cloud-based manufacturing systems, where this concept really started in China, where it was just a conversation among professors and academic and industrial giants, where they were talking about the feasibility of actually having to explore this new concept. So according to Tao, cloud is basically a computer and service-oriented manufacturing model that use radical manufacturing technologies. It looks into your agile, it looks into network manufacturing, it looks to grid manufacturing. And furthermore, it also looks into enterprise information, not forgetting the cloud computing enabling technologies that create the system to be a feasible manufacturing system. And I have said that cloud, it is a virtual manufacturing system. Although it is linked to the physical plant, cloud manufacturing converts the traditional manufacturing system into a service-oriented system, whereby it will use your radical manufacturing models with a platform which is connected to the cloud and physical plant with machineries and equipment connected to a cloud with the clouds of the means of server, and also you'll have your platform for your platform use and the production user domain. But cloud-based is managing the information and data storage for other users and a domain and also production domain. Problem statement. So globally, we're looking into 60 to 70% of SMMEs are creating sustainable employment, whereas in South Africa, we only have 28% of SMMEs creating that sustainable employment, where when you look into things, 95% of businesses in South Africa are SMMEs. So we can see there's a huge gap into it. So we further went to a question, wanted to understand what could be the cause of all this reason. Why are we having so much reluctance from SMMEs not adopting or tapping into these technologies? And we looked into the SMMEs, and it shows that the presence of an IT department within an SMMEs, and we could see that in just manufacturing, you have like 14% presence of ITC department. This is where cloud fits in, because with an ITC department, you need to have your software, your air conditionings, so it's more expensive. It's not really compatible. Whereby when you adopt or tap into cloud into it, it's more custom made for your business. So you pay for what you really need, and you don't have to worry about having an IT specialist in the field or even having an existing IT department in the field. This is basically some literature review that I went through. These are just some articles, and then I further went into looking the transition of the literature that has been going on, how it started into being a concept and going forward to having platforms and frameworks and architecture, and going forward and seeing that it is implemented now. It's no longer a platform, it is a sustainable solution to other developed countries. And they are seeing problems within it, and then you could see that there was also an evolving transition of people seeing that there are problems with optimizing of resources inside the cloud itself, or scheduling, and there's furthermore gaps and opportunities of exploring other things. So, so the aim of this research is to develop a framework for cloud manufacturing implementation, but a case in South Africa. Reason being is, when I looked into the study, it was more concerned about all those well-developed countries. And then there's a huge gap with regards to Africa as a continent, going small and filtering it to South Africa as a country. So my first aim was basically looking into identifying what are the challenges that SMMEs are facing. And then secondly, it's also from this, we assess, okay, these are the challenges. How can cloud assist with these challenges? And then thirdly is to develop this framework, and also fourthly to validate using Plan A gaming simulation. So the method that was employed for this study was a qualitative study. The data was collected through online questionnaires just for safety, and it was easy accessibility, convenience as well. And then I used a descriptive analysis to see from from the challenges that I have identified, do they validate from the questionnaire? Or is it really what literature is saying to us? Does it validate also into SMMEs in South Africa as well? Going further to just more of detail of method. So that's just an example of the instrument. And then, so I was just aiming of having 50 participants, and I think I got 51. So basically this shows that the participants of the questionnaire, and on the other side it shows how I wanted to get the reassurance that am I really working with SMMEs, or could it be another just big giant just trying to help me in my study? So the confirmation of how long you've been in operational. This looked into also operational years, and then in the other side you could see the challenges that I have spotted. They came and said, yes, we have certain issues because of probably funding, red tapes, and other more challenges that I had identified. Also as well, we look further. So I decided not to say using cloud, because not everybody really can understand what is cloud. So I look to contributing technologies, anything that is related with technology into the questionnaire. Remember now, I had to simplify this so that if you are a user, you are able to understand. If I come there with big IoT, what is IoT to me? Or else, if I can ask you, do you have a computer? Do you have a software? Have we ever used Google? You have a better understanding. So I had to literally think of the end user when I was administrating the questionnaire. Okay, so my framework couldn't fit on a slide, so yeah. So now when I was continuing with the study, I have seen that already there was someone in ITC who went and said, let me just create an equation to assess if you have the ability or the readiness of cloud computing solutions. Which furthermore, I adopted that, where I say we first assess the readiness of cloud computing solutions to cloud manufacturing, and then is your SMME ready to adopt these technologies? Because I might be proposing them to you, but realistically speaking, you might not be ready, or you might not have all what is required for you to actually use these technologies. So if you don't have, we'll streamline, and we'll have to understand your business processes and operations and see how we can optimize what you have, the technologies that you have, and see which one can we actually suggest as a solution that would help you for now as you go further. And then furthermore, if you are ready to embark onto this journey, we still have to understand your business operation and processes. And then further, we look into your user domain, whereby user domain is having your partners, your user as in the client, and also your networking, your network, your supply network as well. And then furthermore, we look into the cloud manufacturing platform. This is where you have the accessibility of the plant anywhere, at any time, at any given device, and any moment. So you just open the platform to just track how are things going. Is what I'm expecting at a specific lead time really coming at that time, or is there a bit of delay? So that platform will help you to go around those things, because that's what you really want to see as a person in business. How can you oversee the business without you not having to be in the physical plant? And then now your provider will be worried about your hosting issues, because that's not your baby. All you need is saying, hey, this is my problem. How can you help me? So here it's just basically showing that there are opportunities, but how do we get to reach those opportunities where the provider will be just concerned about anything related to ITC, to also making sure that your information is secured, and your ordering management, resource allocation, everything to do with the making sure the ecosystem of the cloud manufacturing working very well. So I have further shown the identified challenges like your red tape, skills, labor, and funding and crime. So these are things that repetitively were going up in, or you could say I've been repeatedly seeing it in the questionnaires, in literature, that it is still the biggest challenges that SMMEs don't have access to funding because of this red tape. SMMEs not everybody has the financial literature, but if I can say, if finance is a problem, here's an ERP system for you that will assist with the finance, you know? If operations are a problem, here's an EMS system that is cloud-based that can assist with that operation. So this is where it comes to customization into what you require as an end user. So now you'd say, what are the benefits of cloud? So it is quick access to data from any location. Another thing, it enables an SMME to not just compete locally, but even globally, because now if I can access you from USA and you literally have the product that I need, why not? You know, so it creates that, it lower cost and speed, because you don't really have to have an ITC department within your organization, but you're paying your subscription fee, a monthly subscription fee for everything that it's being operational on technologies, which is sorted out. It's out of your hair. It's nothing that you have to worry about. And then it is also proven that in one of the articles in Biz Economy, it says that if SMMEs would embark into this cloud cloud solutions, they also have a great chance of saving 54% in ICT costs, which it shows the return in investment as well. The ability to manage finance and field service, sales. I can go on. The expected outcome of the study is the successful implementation of cloud manufacturing in the transport manufacturing, but not limited to that. Honestly, it can be in any SMME, but because I'm founded by FTMT, I had to link it to transport manufacturing. So in transport manufacturing, and which enables the integration of data sharing, resource sharing, sustainability, and collaborative manufacturing. So with this, we're just trying to create what SMMEs don't have. SMMEs don't have a network that they belong into. You'll find yourself that you're an SMME supplying to a big giant, and you are unable to meet the requirement, not knowing that just the firm next door is doing the same thing. So if you would be in one network, we would be actually capturing this client for us, you know, which creates sustainability, which creates growth. Because a lot of big companies already fall into one network. Most probably a lot of, you find that Mercedes-Benz, BMW, and Ford have one supplier of something, but all of them, they don't know, but they know, you know, that thing. So in industrial case, this is just a picture of how we would be. So if you can see in the central, we have the cloud, which is the internet, where information are, where missionaries are, where your supply chain network is, where everything is linked to this internet, harboring and create network and data sharing, resource allocation. It's just creating that space for flexibility. It's creating that the space for elasticity as well. These are the references based on what I have, and thank you.
Thank you very much, Mika. Thank you very much for that beautiful presentation. Can I ask Dineo to connect? We are really, really pressed for time, so I think I'm going to skip the comments and then we can wrap all of them up at the end, unless if, I don't know, you really, really want to ask that one. Can you, yeah, you I will allow, but the rest, man, we'll talk about this thing at home.
Thank you. I'm not sure if you're the Madam Chair or Madam Speaker. But I think it's important to ask. I think it's important to ask questions because it is a colloquium, so we need to, you know, bout with the presenters at times. So I think my questions are. I think I got confused when you were presenting Mikateku. Like, so my question. I think the first question is your study towards cloud computing or cloud manufacturing? Because I think you, within the presentation, there was a lot of mix-up between the two, between cloud computing and cloud manufacturing, of which your title is very clear that the focus is manufacturing. And then you go on to talk about SMMEs, the reasons for failure, and now you're talking SMMEs and lack of finances, and I'm not sure then how does the implementation of cloud manufacturing specifically become the silver bullet to me as an SMME, that the problem is my customer pays me after 70 days instead of 30 days. So sometimes I can't pay salaries, I can't, you know, pay my other suppliers. And then now this cloud manufacturing, how does that solve my problem? So I think maybe, can you please, number one, give me a distinction of whether your research is towards manufacturing or computing, and then the implementation of this manufacturing or whatever, then the answer will be, how does that become the silver bullet to resolving my issues as an SMME? Yeah, I think because the chair asked us to limit time, I will keep it to those two.
For you,
Okay, so basically cloud computing technologies and cloud manufacturing are married. So you cannot separate the two, right? Because in order for you to have an enabler, you need those cloud computing technologies. So what would differ is the how you create the softwares that you interlink to what you have in your operations. So if you are looking into a manufacturing plant, per se, you will have to create a software that is linked to the cloud and also to the machinery to have that ecosystem in an existence, right? So yes, and then coming back to, there's a going back and forth between cloud manufacturing and cloud computing is that, as I said, they are married to each other. You don't have cloud manufacturing if you don't have cloud computing. And for other SMMEs, it's that maybe cloud manufacturing, it's not what I need. I just need maybe a cloud-based ERP system. So I'm saying there are other options. So I'm telling SMMEs that because the study had to be directed into manufacturing, I had to have that focal point of focusing to manufacturing. But there isn't any limitation. So meaning if you are in finance and the problem is you can't balance your books, so you have to have a cloud-based software that can assist you with that, and you have it on a backup. Unlike if the factory gets burned, you don't have a way of having a recovery or a backup of the information that you need. In terms of implementation, definitely hence there is an assessment model where we check if is there readiness within your company to actually adopt this cloud manufacturing. Because that's what you need to know. A company can be business ready, but it might not be technologically ready. So now, how do I give you a game plan to this is our end goal. Our end goal is that for you to exist in the network of a cloud, in an internet, a business so it should appear. You know, besides the Facebook page, if I'm taking you as a serious investor or a potential buyer of something, I want to see who are you, where can I locate you, even if it doesn't mean me flying into SA, you know. So giving you that credibility that I am an existing business and I'm sure you'll get the product that you're looking for. So we have that. A lot of SMMEs are really scared or have their own perception as well with regards to this technology. Hence, there's also that not a lot of SMMEs would know that there are certain companies that are actually offering these hosting space or these cloud space for free for them, but because they don't know, they don't have that access to that information. So also, having to create a network, knowing now someone is doing the similar business with you, it creates a survival, because I can come to you for my stock, for a person who needs the stock tomorrow, and you have it, I don't have it, but the client is with me. So we're also creating that value chain. So hence I had even said in the model that, well, once we check your readiness with regards to technology, and we see, okay, you just have these technologies, how can we optimize them for you? How can we assist them for you? How can you see the value in these assets or technologies that you have invested? I hope I answered everything. Thank you.
Thank you very much, Mika. Okay. Isn't that your PC? Okay. Thank you. Dineo, can you approach the stage? After that, we're going to have Mr. Ua, and then we're taking a break from the student presentations. We're going to listen to the hustlers. So, Dineo, your time.
Good afternoon, everyone. Thank you, Madam Speaker, for the opportunity. I know we are running late, but before I start, I just want to say a little bit, 5 minutes. I know Prof Mpofu, I can see Prof is not here, but I wanted to say something to him. Firstly, I am doing my master's in polymer technology. I did my undergrad, graduated in 2000. So that's 22-year gap there. Why am I here? Firstly, it's Professor Mpofu. He's the one who encouraged me to come here. Why? I've spent 15 years of my professional life in the automotive industry, in the development, product development, meaning in the engineering side. And then I left corporate. I've been on my own for the last 5 years. So when I was talking to him, he said, Dineo, I want you to come join this program. I can see you've got a skill as an entrepreneur and the zest for it. So this is why I'm here. And he said, I want you to come up with a project that we can build a business case from. And it took me a while to finally, eventually come to this project, which is techno-economic analysis of industrial polymers in the transport industry. And the focus will be in polycarbonate. So I wanted to just give you that brief to say, we are really, like he said, we are willing to, convert this project and this researchers into business cases, not just on paper. Okay? Like I've already said, I'm from the Department of Polymer Engineering, and I'm going to be simple. It's still, this research is still on proposal, on proposal, not yet approved. So I'll just take you through my introduction, aim and objectives, which methodology we are going to use, and what is the opportunity, within the industrial, within the business, and what are we expecting to, to get out of this presentation or this study. Okay. So I'll be talking about, my focus will be on engineering polymers. I'll take you through to it. So I'll also talk about, the opportunity. Why do we need to reduce our vehicle weight? So we are going to look at the need to reduce vehicle weight. And also, we are going to look at, the need to go green, the drive to reduce greenhouse gases, which is mostly associated with carbon dioxide. That's one of our drives in the transport industry. Also, we're looking at, to improve our fuel efficiencies. And lastly, we're going to look at reduced maintenance costs in terms of parts replacement, okay? So I'll just take you through what is engineering polymers. Our engineering polymers are mostly, polymers in the, you can see them there, the engineering polymers. It's your polycarbonate, your TPU, your PPO, and why the focus on engineering polymers. Engineering polymers are mostly used in the manufacturing side. They are strong, so they are rugged, and they are also easy to work with. They are not as difficult as other polymers. So that is why we call them engineering polymers, and that is why the focus will be on it. Like my title is already saying, the focus will be mostly on just polycarbonate. And then maybe you might ask, why polycarbonate? I'll explain to you in that side later on. But also, we want to also look at what is happening globally, with regards to the use of polymers, polymers in the transport sector. As you can see, especially you can just look at the automotive industry, that trend is actually growing. I think we are looking at something like, they're forecasting a 6 to 8% growth, to up until 2027. So there are opportunities there, and the industry is looking at, improving the numbers. So we are looking at replacing more and more parts with polymers in the transport industry. So the opportunities are there, and the market is willing. Okay, again, but if you look at South Africa, where we are, it's very, very low. We are currently sitting at 4%, and you might ask yourself why. And I can give you one reason. It's because we are not localizing enough in South Africa when it comes to our plastic components. We are still importing a lot of this material. So we want to also improve on localization opportunities, to say where are the gaps, what can be done in that sector, which is, part of transport, and where are the opportunities, and, how can we now localize these components so that we have them locally instead of, importing everything overseas, which is also part of, creating employment. Okay. Again, I'll take you through, you can see, the use of engineering polymers in the US, the estimation, you can see where the market is going, 7.4 increase estimated compound, increase in the future. So, yeah, there's a lot of opportunities there that we can take advantage of. Why polycarbonate? I chose polycarbonate for this case because it's got excellent heat resistance, high insulation, electrical insulation properties. It's very transparent. It's 250 times stronger than glass, but it's 6 times lighter than glass, and it's got high toughness, and it's fully recyclable. If you can also look, all those other polymers compared to it, PC comes very on top. So it's a very good polymer to look at, and the characteristics talks for themselves. Okay. And then again, we look at where are we with greenhouse gases? Already we can see that the transport industry is second after power with regards to the contribution to emissions in South Africa. Is that good? Is that bad? We all know it's bad, so we need to reduce that. If you can see already in SA, we are sitting at 86% of our GHG contribution. and mostly from the transport industry. Already the transport industry is contributing over 42%, which is a lot. So that's another opportunity. Okay. I've already mentioned that the transport is a major use of energy, and we need to look at ways to reduce this. And we know, like I mentioned, we are going light, so the lighter you are, the less emissions you produce, and then even your fuel efficiency improves. So just replacing one component, one heavy component with a lighter component, then we'll meet a lot of three things, okay? So what is the aim of my study? So with my study, I'm going to develop actually a model, which is, we are going to develop a we're going to do a techno-economic analysis for polycarbonate production. I'm only going to focus on polycarbonate. I'm not going to, compare it, with other things, but opportunities will come. So the first thing that I want to do is to develop the cost estimate for polycarbonate. Then I'll develop a model using an Excel spreadsheet to show the cost estimate of polycarbonate. And then from there, I'll do a sensitivity analysis model to determine the impact of the financial indicators. So what are we actually doing? I'm actually trying to see, is it feasible to use polycarbonate to replace other components? Is it cheaper? Is it cost effective? Because you just don't want to go and say, I want to replace this component with this component when you don't know the end effect that it will cost you in production, Okay. So that's what I'll be doing mostly. So my research will mostly be, it will be a desktop, no experiment will be conducted. I will be, using financial variables, which is my NPV, your net present value. I will look at my IRR, my PI, and my low cost of energy. Meaning we're going to create all those models, all those variables. But what I've decided to do, just to narrow it, I'm going to look at glass for now to say, if we replace glass with PC, will it be financially feasible? So we'll do that. We'll do a comparison on glass, and then I'll also do a sensitivity analysis, to compare the financial indicators to say, is it, feasibly okay for us to move on? Like in this case, if we look at the net present value and it's less than 0, then we know that it's not going to be financially feasible. But anything greater than 1, then you know that it is worth it to invest in such a product or in such a technology. Okay? So my methodology is simple. I'll do a desktop study. I'll develop a model using an Excel sheet. Then we'll do a sensitivity model. And then from the data gathered, then we will conduct and see if it's technically feasible to continue with the process. So that's it. And I'm just going to do this on polycarbonate. But then, like I said, for the purpose of this research, I'll be comparing it with glass, just to see if they match and if there are opportunities for us, financially to replace glass with polycarbonate. Okay. So I'm not going to go in. So what are the opportunities? We say, where are we using glass in the transport industry? We are using glass on your windscreen. Your windscreen is glass. Our side windows is glass. And they are heavy already. We've already mentioned that. And we've already said polycarbonate is very light. And it's got almost the same properties, which is transparency, but it's also stronger than glass, but lighter than glass. So opportunities are there that we can develop. We can have we can start having discussions around that area. If our study comes out that it's financially feasible for us to replace polycarbonate, then we can start looking at replacing those components with polycarbonate. And then also the model that I'll have created, can be used for other components too. Does not necessarily have to be glass. So we can take the same component and say, if I want to use PC, which component am I replacing it? And then you use the same study, because it will be there. The formulas will have been created. And also we can, it will bring in another side where polycarbonate is fully recyclable. So there's opportunities in having recycling companies, or also reselling the material to create, for other opportunities that they can use it. So those are the opportunities that we are looking at with regards to polycarbonate. Okay, so that's it from my side. So what are we expecting out of this study? We are just, we want to just make sure that it's economically feasible or not to replace traditional glass windscreen and side windows with polycarbonate. That's all. Thank you.
Thank you very much, Dineo. She said to me, you must give me my time. I want to sell my idea. Have you managed to sell it? I don't know. If you achieve your goal, is it enough for your doctoral studies? I don't know. Let's hear from the house. Do we have questions, comments? Give her her flowers while she's still here. I can't really. Okay, I think it's Ms. Mufeba.
Thank you. Ms. Malungana, I know you are not doing a lab development or any lab work, but with polycarbonate, it's not scratch resistant. Have you read maybe in the literature if there are other additives that are added to overcome that challenge?
Any more questions? Okay. Maybe we can just take Dr. Danian's question too.
Yeah.
Thank you so much for that presentation. Please, can we go to your aim and objectives?
Pardon?
Your
Please,
objectives
can we
again.
go to your aim and objectives of study? Your aim and objectives.
aim,
Yes, please.
okay.
Can we go there, please?
Mr. Ua, please don't go.
Yeah.
We have you after this.
So I will suggest that the aim is open-ended to develop techno-economic analysis for polycarbonate production. So it can be tailored down to a specific application, maybe a specific industrial application, because all these applications, they have different functional and service requirements. So I will advise that. Then secondly, in addition to what Ms. Musikwa said, another weakness of a polycarbonate is that it has low thermal expansion, low coefficient of thermal expansion. So in addition to what she said, low thermal expansion and hardness, low hardness. So how do you plan to mitigate these weaknesses so that it can be suited to what you plan to use it for? Thank you.
Any other questions? Any other questions? That's all.
Dr. Mabalani, I think he wants to say something.
It is not a question, but it's a comment because of I'm familiar with whatever like she's doing. So basically, Dr. Danian, she's not that focusing on the production of polycarbonate, but only focusing on the cost aspect with regards to the polycarbonate, because of the polycarbonate is being there, it's produced. So now she's working hand in hand with a certain company. I don't know whether like she mentioned it.
No, I think Paul, yeah,
Okay.
maybe let me, yeah, thank you.
Okay.
Yeah, I wanted to ask both, answer both Musikwa and Dr. Danian. So what's happening here is, the opportunities are there. So the polycarbonate is there. The application is not yet there. Like we haven't gone from replacing polycarbonate with glass in South Africa. But the proper polycarbonate sheet with the right, that has the low scratch resistance, Musikwa, has been developed. And all those other components that you are talking about, Dr. Danian, the thermal, the low thermal temperature, yeah. So the component is there. We just need to, before we cross over, make sure that it's economically feasible. If you take the production cost of polycarbonate and you take the production cost of glass and we look at all the financial indicators, does it make a good financial decision for us to do that? That's all. So it's not a new product. Both products are existing, nothing is new. And there are components, there are other industries already, the rail, there's a bullet train in China that is using the polycarbonate windows, but we don't have their study on what has happened. So we want to look at it from the South African, angle to say, are we going to, is it a good investment or not?
Are we happy with the response? Do we have any other comment? Okay, yeah.
Definitely it will be a good move, ne? Because currently one of the challenges that we are faced with is vandalism. So even with the trains that we are producing currently, the customer is quite concerned because the cost of replacing this lateral windows, windscreen is quite high. So this is one of the, I think, initiatives that we also started to look into. But also from the old yellow trains, they do make use of I think polycarbonate. So yeah, it's actually something that will answer to the current problems that we have. Thank you very much.
Thank you.
Any other comment? If not, thank you very much.
Thank you,
Ms.
thank you.
Neo.
Thanks for the opportunity.
You are welcome. I believe people with similar studies should just actually sit down, compare notes. I was listening to the SMME presentation. They're talking about the challenges that happens there. So I was thinking, Mika should sit down with Alice because now they're talking about the challenges. Maybe they can tackle them one by one. Who knows? So Mr. Ua, you are standing between us and our tea. It's outside, it's ready. So I just want you to know that what you do with this information, it's up to you. But I'm gonna give you 10 minutes to talk about the mechanical property dependence on grain growth in quaternary aluminum-based alloy for automotive application. When you are ready, Ntate Ua.
Good day all. I'm by name Chukunonso Owa from Mechanical Engineering, and I'm majoring in materials option. Then the title of my presentation is Mechanical Property Dependence on Grain Growth in Quaternary Aluminum-based alloy for automotive applications. Yes, if you can observe critically the title, you can see that we have two variables. We have independent variable and dependent variable. The dependent variable there is the mechanical property, while the independent variable is the grain growth. Okay, now, how do we manipulate the grain growth, which is an independent variable, to affect the mechanical property of this aluminum-based alloy? Before I will go further, you can see the image there. There's a component we want to address, since it has to do with transportation. Okay, now, we now come to this triangle. In this triangle, we've seen the processing, that's the processing route. You see the structure and the property. Anything that has to do with materials must undergo these three processes. The processing route, how does it affect the property of the material? The processing route, how does it affect the structure of the material? Then the structure, how does it affect the property of the material? Now, let us explain this. There are many processing routes that can be used to fabricate aluminum alloy. Then, how does the processing route which I've selected, how is it going to affect the property? Then property of a material is divided into two. We have mechanical property and physical property. So mechanical property has to do with strength and the modulus. Any other thing that is outside modulus and strength falls under physical property. Electrical property, chemical property, all of them are grouped under physical property. So there are two types of properties to be investigated: mechanical property and physical property. But this presentation is limited on the mechanical property. Then the structure has to deal with the microstructure. So relating it to the title, it means how does the microstructure, which incorporates the growing roots, affect the property, which is the mechanical property of this aluminum-based alloy. Okay, with that, we'll come to hypothesis. So we have to formulate a hypothesis or a research question that will guide us in this research work. Then we have null hypothesis and alternative hypothesis. So from the null hypothesis, we can raise the question like, there will not be a significant effect between the grain growth in quaternary aluminum-based alloy and its mechanical property. There will not be. It will not affect. The grain growth does not affect the mechanical property of the material. The alternative hypothesis says there will be a significant effect between the grain growth and the mechanical property of this aluminum-based alloy. Then, also, how does the reinforcement affect the aluminum matrix? When you hear about an aluminum matrix, aluminum is the parent material. The reinforcement has to deal with the constituent elements that is being added to aluminum to improve its property. Okay, now the question says that how does it have any significant effect if the reinforcement? And the reinforcements are considered, they are copper, niobium, and polydenium. There are three constituents which you can call fillers that will be used to improve the parent material, aluminum. And we should know that aluminum has really attracted the interest. It has attracted interest in the field of engineering because of its potential properties. It possesses low cost. Then it is corrosion resistant. Then it has lightweight. Then it can also reduce environmental pollution. Then talk about fuel consumption rates. We'll talk about energy efficiency. Then prolong the automobile lifespan. So that is why the industry is focused on aluminum. Then let us go to address the problem statement. The problem statement, if you can look at the image, although I included other factors, like corrosion can also contribute to that, where I remember this ring here, it stands in between the engine block here, and it incorporates the piston with the connecting rod. So this will lap here. When it laps here, the one in use is copper. So when it laps here, which is stationary, and a rotatory part, So at times, based on corrosion and vibration, because when vibration takes place here, we are talking about fatigue. Also, you can observe wear, corrosion, and the kind of impact, some impact factors on it. So it gave room to this problem statement. The strength of this ring is being determined by the microstructure of this component. Okay, now, 4 minutes for waiting. So now, what do we do? Then we'll now come to the objective. What is the objective of this, this presentation? The objective is for us to come up with a strong aluminum-based alloy that can be used to replace the existing copper that is in use in that component. So now, okay, so then I have to consider the properties of the metals, of the materials, engineering materials. Now you now see their properties, electrical property, tensile property, strength, density. So that was why I had to come up with the materials. Then now, if you consider aluminum by nature, they are plasticity in nature. Aluminum, pure aluminum. This is a pure aluminum. So this is an aluminum alloy. So that is ductile. Now, when I come to this is the microstructure. This is the microstructure. This is the microstructure. Then let me explain grain growth. The process I used, look at the process route, look at the powders. They are powders. So we have aluminum powder, copper powder, niobium powder, polydenium powder. Then for even distribution of the micro size of the particles that are in this powder, it has to pass through mixer. So from this mixer, it has to mix it for 24 hours for even distribution of the elements. Then after which it has to be sintered with spark plasma sintering. So in spark plasma sintering, I had to place it on a constant pressure of 50 MPa. Then the temperature was varied from 250 degrees Celsius to 48 degrees Celsius. Remember, aluminum melts at 660 degrees Celsius. So when it's being sintered, you have to come low or 3/4 of the melting temperature. So that was why I did not go to 600 or go to 660 so that it will not melt. So now, after which it will be characterized for the properties we are investigating and also the strength. So from there, I had to use, these are why I used the SPS. Then the industrial base case. Industrial base case, all these factors make up to contribute the industrial base case, the material availability, and the material cost. I think aluminum is available in South Africa. Then the manufacturing cost, as long as we achieve the motive of these components, I think it will be cost effective. Then the usefulness of the material to automobile industry and utility companies, even for ESCOM. Anyway, the primary aim of this material is to reduce sag on long distance transmission line, which contributes to explosion that may cause blackouts. So the existing material, aluminum alloy material in use, they expand and cause sag. So based on some environmental factors, they can meet, the lines can meet and cause spark, and there will be blackout. So now it will also contribute in job creation. So I want to say the idea to the industry so that they can venture into this concept, because the world has turned to aluminium. Thank you very much. I acknowledge TUT and Gibela.
Thank you very much, Mr. Chukunonso Ua, for that. For that good presentation. I think we have so many materials that we can just open a business and create jobs. What do you think?
Yes. You know, materials material is divided into three.
More enthusiasm will help, Mr. Ua. You must sell this idea. Let's listen to the House, what the House wants to say. Do we have questions? Do we have comments for Mr. Ua? Okay. There's, is it Bibili?
Thank you very much. Thank you for the presentation. I just see that our work are aligning together. Maybe we need to discuss. My question is more about which of the aluminum alloy are you considering for your study? If it's pure aluminum alloy, which class of the aluminum alloy are you looking at?
The aluminum alloy, which is the parent material, has a composition of 99%. It's a pure aluminum, which I bought from Alpha. That's the supplier, the name of the suppliers. So now you can see it is in the laboratory scale. So when all those hypotheses are tested and validated, they then means it will now go to pilot, from pilot to industrial scale.
Thank you. Mr. Saka has a question. Am I right?
Chief, just a simple one. How are we going to implement this and make this impactful? I mean, we're talking about alloys here. We have a train that is very heavy, and there's HCOM who keeps on taking away our power, and we want to make sure that we reduce this this electricity that we are using. So how can we apply those alloys of yours to reduce, you know, the weight of the bogies and the wakes, you know, on the train, so that we are able to go faster?
Just like in one of my presentations, when I was working on polymer and ceramics, which are under materials, aluminium has gone a long way to replace steel, because steel is characterized by its weight. Aluminium has a light weight, but it's not strong. But some of the aluminium, when it is an alloy based on the composition, which now improves the mechanical property, some of them are stronger than steel. Yeah, that is it. Because of time, I told you now, when you come to these mechanical properties, I can name it for you. You now see copper has 129, aluminum has that 70. So, and niobium. So when you vary them in the composition, then they will now improve the aluminum. That was why I said the aluminum on its own as a pure material can deform. Aluminum on its own, this aluminum on its own, pure aluminum, it deforms. But when all these additives, all these fillers are used to improve the matrix, then it can be ductile. This is ductile. The other one is ductile. I don't know what is wrong with my hand though. This one. This one is daughter. Yes. This one is daughter. That is a material property or mechanical property, physical property that can withstand stress or strain and can change from one position without the strength being disturbed. While the other one is plastic. The plasticity is deformed under force, applied force. So this is pure aluminum. This is aluminum, which the property has been improved.
Thank you very much, Mr. Ua. Let's not have a dialogue. Thank you again. Thank you so much. I was only wondering if this is your doctoral study or is it just a piece of it?
No, my work tends to patent, so that is why I cannot come to discuss about the results. But for now, let us use this part to improve this component.
So it's a part of it.
It's a part of it.
Thank you very much. What's going to happen now is we're going to take 10 minutes, stretch our legs, have some tea, coffee, and those spices there. I saw there's cayenne, turmeric, add all of them, get some energy. We come back, and then when we come back, it's like we didn't forget about the discussions we had in the morning. We have identified opportunities, we have identified problems, we have had discussions with our incubatees or our entrepreneurs. I don't know if they want to be incubatees or entrepreneurs. And then Ms. Muraro also gave us a lot of opportunities. So when we come back, we're going to hear that from a hustler's perspective. So let's respect the hustler and be back immediately after 10 minutes. Thank you very much. Enjoy your tea. Oh.
sawa. Hustlers. What do you mean, hustlers? Eh? What do you mean, hustlers? You're literally doing this. And you don't. No, I mean, I'm talking about the channel itself. Yeah. Where I push it too much and it becomes loud.
Until it was after when I saw one see that.
Yeah. Yeah.
And monada. I'll tell you no, put out the fat.
You don't have to. As long as you can hear the person. Yeah. The rest. Yeah, because sometimes. Two. Hey, hey, hey. Okay, okay. What do you want to after? Lama mic, alingile lama sound.
Do they listen, Prof?
Who are they? So that they just come, nobody
do
comes
they?
with their, huh?
Do they? I did that several times.
So who's
And
next?
also, I asked them to give the presentations to Alice because the online people cannot see the slide. Let's take our seats. Let's take our seats and continue with the program. As I'm looking at the program and the minimum 15 minutes time given for each presentation, it means we are going to leave this room at 19:30. (7:30), that will be the time when we leave this room. Let me remind you that for everyone who's going to present from now, ensure that either your computer is ready or your presentation is in the central PC. As well, don't forget to give Alice your presentation. Why? Because the online attendees cannot see your slides. So when you are presenting, Alice is running the slides the same way as you do. So ensure that Alice has your slides, and then ensure that it's either your PC is HDMI ready or your slides are in that computer that is at the center. I don't know where it is, but I think it's on the floor. So now it's time. I don't see our hustler. What happened to our hustler? Please do. You want another speaker? Rumbi is not here. Yeah, but we can skip. Also, after him, it's supposed to be Rumbi. She's not here as well. Nolutando, how many minutes do you need? 7, questions included, right? All right. So let me give you this time because our speakers are still enjoying the cayenne. Nolutando Mzima is our 3rd undergraduate. She's our 3rd undergraduate presenter for this workshop. She is in her 2nd year of BEng Tech Industrial Engineering TUT. She's also a very active member of the SAI student chapter. Yeah. Remember, we've been starting, stopping, relaunching, stopping, relaunching the SAI chapter, but for the past 2 years, it's been running like a well-oiled machine because of these leaders. I don't know why they didn't tell you yesterday that Sbu is leading it. Yeah. So he's doing that with assistance of Nolutando and Tato, who was here, and many other of our active members. So this is a poster. She's going to take maximum 7 minutes to explain to us what is her idea. Mem Zima, it's your chance.
Good afternoon, everyone. Thank you so much for the beautiful introduction, Madam Speaker. I'm not going to take 2 seconds from your time with introducing myself. I'll just get into it. My topic is developing a fully functional electrical vehicle to reduce the greenhouse gas emission. So, for this topic, my introduction is with the growing demand of the reduction of greenhouse gas emission, there's been a global interest to introduce alternative modes of transportation, transitioning from the conventional, which is gasoline, to electric mobility is the new normal. E-mobility holds tremendous potential in transitioning towards greener economies. However, here in South Africa, unfortunately, the adaptation of these technologies is very slow. So the aim of this project is to develop and manufacture fully functional electric car vehicles to reduce greenhouse gas emission through designing and testing. The project also aims to help expose the technicians and engineers of the country to these technologies. So for my methodology, I have taken the route of thinking of ways on how to actually gradually move to the electric vehicle systems in South Africa, because as it stands, we are still not fully, but a higher percentage of our vehicles are the gasoline vehicles. And with the fight that we have of global warming and climate change, we are really trying to move towards being greener than and reduce the carbon footprint that we have stained our planet with. So my methodology goes as follows. We are going to gradually introduce e-mobility, and by doing that, we'll be trying to transition from the traditional ways of our economy. I'm sure we all know in here that our economy is driven mostly by fuel, and now it's going to be a challenge to ditch the fuel-driven vehicles and move to electric, I'm sorry about that, fully functional electric vehicles, because now we would have to put our economy at risk, and I don't think our government really would be excited about that. We will also be working on converting some of our gas stations to electric charging stations, and this is because we don't really want to start from scratch when we already have things that are in place. We are trying to gradually transition, not add more things on top of the ones that we have. So by by converting gas stations into electric charging power stations, we would be now accounting for the introduction of electric vehicles that we are trying to implement. Secondly, I'm going to introduce a dual manufacturing system. So I'm sure you're already asking yourself, how are we really going to gradually transition from gasoline to electric mobility? The plan that I have is to adjust the manufacturing model. Already we have car manufacturing plants which are mostly producing gasoline vehicles. And for us to slowly transition to the electric mobility side, we are planning on having a dual manufacturing system, and this will work in a sense of having two manufacturing lines where the conventional gasoline vehicle will be manufactured as usual, but now we will try and have 1 out of 10 conventional vehicles to turn them into the electrical vehicles, so that this transition doesn't become a drastic transition, but just a gradual transition to move to the greener economy. And then my third methodology is circular economy. In the process of manufacturing, we know that there is a lot of scrap that is acquired by applying the principles of circular economy. We'll try to recycle, remanufacture, reuse, and reduce the carbon footprint. The figures that I have placed on my poster, the figure 1 is the integrated electric motor. Figure 3, which was supposed to be figure 2, that was a mistake on my side, is the process flow chart of the dual manufacturing system. And on figure 3, I have the process circular economy that we will be implementing to achieve this goal of developing a fully functional electric vehicle to reduce the greenhouse gas emission. Thank you very much. That will be it.
Thank you very much. Thank you very much, Nolutando, for that beautiful presentation. Don't tell them your mistakes, let them find them. If it says figure 3, it's figure 3 for you. If they're not comfortable, yeah. That was beautiful. Do we have comments for Nolutando? Our undergraduate student. Mr. Sak, we'll start with you.
Don't look at me like that, please. I'll be nice. Okay, first things first, right? One of the key things that you need to consider is something like production costs. Having a second line, I think Gibela can attest to that having 2 lines is very expensive. So you need to be very careful on what specifically will be on the second line compared to what will be on the traditional conventional vehicle line, okay? Second thing as well, when you look at it, right, South Africa is just one of the suggestions. South Africa is a very hot country. Especially if you look at Limpopo, Northern Cape, and yeah, those 2 provinces, they're very hot. So something like, when you're considering this e-mobility, look at solar powered vehicles. We're working on a mobile electric vehicle. I think, yeah, it can be good to have somebody that can understand the system, and then we'll definitely talk offline and see how we can slot you in the team.
Thank you so much. Thank you so much, Mr. Charles. I'll definitely look into it. And with regards to your first comment about the cost of introducing a new line, the strategy behind this is to not necessarily have a different line that will be introduced, but since the actual vehicle is not far from the manufacturing of the electric vehicle is not far from the structure and all the components that are on the outside. The only different component that is added into it is the electric motor, which is the one that, the electric motor and the wiring of the vehicle. So as much as there will be cost, but they will be worth it, since from Ms. Gaugelo's presentation from yesterday, she did mention that productivity is sustaining life, and we are actually on the road of sustaining life. If we don't come up with these ideas and implement these solutions, but in the next 30 years, we'll be facing more problems than just global warming. Thank you.
No further comments. Thank you very much, Nolutando. And Tate Kulegani, we are ready for you. Thank you. Nolutando, if you get this one right, Yeah. You might find yourself skipping honors, big techs, and all of this, jumping straight to PhD. Don't tell people I said so. This is a safe space, you know, okay? It's a safe space. What happens in, where are we? What happens in Glenburn stays in Glenburn. So we haven't forgotten about the opportunities that were raised this morning, and now we are going to look at them from a hustler's perspective.
Oh, on a different screen. Okay. Oh, there it is. Okay. Perfect. Okay. Good afternoon, everyone. Yeah, I think my nickname for this conference might be All Protocol Observed. Yeah. I trust that you're all well, and thank you so much for the opportunity to be around possibility. You know, there's the energy of anything can be achieved. What is possible is being realized. You know, even if it's through research or at a research stage, at a prototyping stage, you know, some commercial stages. It's quite exciting to be around such excellence, and I think you should give yourselves a round of applause, please. Okay. Yeah. So the aim of my presentation is really, you know, looking at the GROWS rather workshop key outcomes, and really trying to align them with what's happening around the world, what's happening in the country, and what's happening with industry. I think it was a key guided alignment from the honorable members from Gibela, and it's something that I took very seriously. So I just looked at NatMap 2050 and South African level DOT, and looking at transport as the heartbeat of the SA economy. So it's a reality. Everything has to be moved, you know. And if you want to eat tonight, that bread must be moved from somewhere, you know. Or whatever it is that you're eating. Bap, you know, some might be eating, you know, McDonald's, or, you know, local chicken licken, anything. So that's the reality. Transport is the heartbeat of the economy. So around that center, what else is happening in our economy? So SA's got a economic recovery or economic reconstruction and recovery plan, which is moving very fast. You know, SA was able to gain, you know, a couple of the outcomes in that plan. You saw the 1 trillion rand. You know, that was an outcome. It was achieved, and now we're speaking accelerated adoption. So it is a reality, and the time is now. You know, luckily we're in a room full of people who are industrializing, and which is one of the outcomes of the economic reconstruction and recovery plan, which is in the outer circle on the left-hand side, on my left-hand side. So, of course, there are many more players. I was just able to highlight a few, but the focus is really in the center, what is the ecosystem, what solutions can we solve? And I'm premising it from a Ramsari enterprise ecosystem perspective. And so you'll notice on the right-hand side, there'll be changes which are highlighted as I continue in the presentation quickly. So I'm sure by now you know me. I'm a TUT alumni, a National Diploma in Industrial Engineering, and I use a lot of the knowledge in really enterprise architecture, more operational excellence from I guess everything, but system analysis and design. But it really, what really captured me was capability maturity, and as well as the whole automation and technology part. And I'm now doing a BSc Informatics degree at UNISA. I've done short learning programs, 6 months UNISA, SQL. I did a costing 6-month short learning program, UNISA as well. So I really tried to upskill myself, and I've done more courses, which are more relevant to today, enterprise architecture and the likes. But I can say post-university, I really focused a lot of my energy on really gaining knowledge, because you really need to understand what are the standards, what's being done out there, and getting yourself certified to actually get into those doors. You need to show that certification that, oh, this individual does know the work. So that really helped fast track me to create a company called Beta X, and we tried to align also with South Africa's Bill of Rights. Really looking at as a core value of our company, we were people before profit. So if you miss out on the people, then why are you in business? That's my premise. I do not want to profit at someone else's pain. So I think the Bill of Rights was a great framework, for me to look at. And my company focused on digital transformation, environmental sustainability, reducing poverty and inequality. So that's number 22, 27 Bill of Rights, education and skills development, and mobility, which is why I'm here, and alternate energy. So so without really going too much about what my company does and partners and the likes, from a streamlining of RSA's plans globally, if you can see, something is happening now with that Ramsari circle. We've got the heartbeat, of the economy, which is transport, but around it, you've got the UN SDGs, and I just tried to align some of government's economic reconstruction and recovery plan priorities. On the left, bottom left, is intervention around energy generation, and of course, very important, interventions around employment. There are many more, but if you look a little bit higher, I mentioned reversing the decline of the local manufacturing sector and promoting reindustrialization through deeper levels of localization and exports. And I think it's quite exciting because Gibela is really pioneering this, I think, for the country, and at least in the real context, perhaps even beyond. So there are a lot of other government projects that are running around industrialization. So I've got a scope in the ecosystem around technology and the private sector. So the relevant ones, which I think we are speaking about today, are on the right-hand side, on the left-hand circle, in the government sphere, is the Economic Reconstruction Recovery Plan, which I mentioned. You've got the Regional Transport and Integration Strategy. There was a manufacturing, supply chain, cloud manufacturing application. Already, you can plug that into a larger scale. Now you've got a national scale supply chain management solution, So, that's, I've just highlighted the green transport strategy, there's many ways to explore, but I think it'll be much more interesting when I speak about it visually. So I just want to skip this slide. Okay, so if we're looking at it from a private sector perspective, if you look at it on the right-hand side, in maroon, one of Ramseri's, I guess, priorities that I've highlighted is really creating R&D technology solution for enterprising. And if I'm looking at it from the context of this workshop, I've highlighted on the bottom left 4 projects or presentations that were made, which I think can really help to, or can be enterprised for the private sector, and particularly Gibela. So, of course, we have to look at high priority areas as we were guided. So, sorry about that. So, priority number 1 is process optimization, 6 rail carts, train sets per month. So, yeah, it's quite amazing that Gibela is doing this massive, I guess, upscaling, and I like what was said. At face value, it's one more train set, but the reality is that supply chain needs to be able to scale up very quickly. If they were already late, now they've got more products to deliver on time, and they also have suppliers. So I think process optimization on the left-hand side, bottom left, there's a facility layout optimization simulation software, which I just gave it that name. Professor Nzelele presented that on day 1, and I think it's really the quick win, because if your suppliers are late, at least you're from an operational side. At some point, I worked in a manufacturing plant in continuous improvement, so I definitely do understand the value of tech time increase. Even if you increase by 0.2 seconds, that's a lot more products produced a day from a financial side. It could be even 2 million rand more per day, or even more. So if we're looking at it from an ROI perspective. And then priority number 2, customer experience solutions. I like Mr. Trevor Shondler's application of IoT in product and service development. I think that really speaks to any sort of solution, and I like how explorative Gibela is willing to be around custom experience solutions. And if you have a framework of how you can apply that, say for example, if we're looking at collecting data in the train, collecting data at the train stations, if you really have a productized or productization or servitization framework, it's much easier to start and say, okay, let's collect, obviously with consent, Popia. Look at, customer profiling. Let's look at, frequency of movement in a certain corridor. Let's look at how many people get on this train in this, towards this rail corridor at this time. And we really start to get a sense of the patterns over time. And I think, there's so many solutions you can develop around that. How do you make, even from a franchising solution, where in business you can create customer solutions by solving a problem with ice cream, for example, people or milkshakes. If you actually create take a small business which sells milkshakes, it might actually make the train ride, feel shorter, and more people will catch the train, and have food and have their supper on the way home. So it might solve the problem of eating supper or going to buy food. It might even reduce crime, because now you can use your train ticket to buy food at the train station, and now you don't have to use that route, and it's so late and you don't like using, because it's dangerous to get home, in the township. So there's a lot of subsequent in terms of ripple effect solutions, which can be solved using ice cream. So, yeah, or from a retail perspective, using customer experience solutions. So, yeah, so that's the application of IoT by Mr. Trevor. And then priority number 3, digitized OEM supply chain SKU tracking. I can imagine, I can only imagine the bill of material of a train. I know the bill of material of a car. I've been in JIT, automotive manufacturing, for 3 years. I once ran a door panel production line from Pretoria North to Pretoria East, into the actual car. So I know all about optimizing, onto the truck, and then to the distribution center, 2 months safety stock, etc. So I really understand the reality of being able to track, okay, where this product might be. We might have a buffer, storage area, and we don't even know that we have those parts. Or if there's, for example, import challenges, with wars, things that are out of our control. How do we know how much safety stock we have, And if we can't really digitize our SKUs, what are we using as a reference? So I think that's definitely, a really quick win. And especially if we have a cloud manufacturing framework that already exists, it's easy to even plug and play a commercial solution that already exists and really see how we can, utilize the industrial engineering department to really just try to create SOPs for this off-the-shelf solution, and quickly run it on one production line, maybe on your slower days, just for an hour, and slowly but surely migrate, increase to 2 hours, 3 hours. In 2 months' time, we're running, even if it's an off-the-shelf solution, but we've digitized, our supply chain management, and there are many solutions out there with reliable service providers, which I do know of, by the way. So, and I am partnered with. And in terms of high priority number 4, electronics backlog and lead time risk. I think I added lead time risk because, yeah, it's I think solution number 3 solves that in a way, but in terms of getting the actual products, getting the actual electronics, which are, there's a huge global shortage. Of course, remote working happened way quicker than we all planned, So there's obviously going to be if we're all in manufacturing, we know that you don't just scale up, It costs a lot of money, and you're not really sure when the demand is going to go down. You're thinking about ROI. If I spend 10 million rand, to manufacture more products, what if, everyone gets, what if remote working is only a temporary trend, So you can't really make those manufacturing technology decisions, at a go. You have to just, wait it out, try to work overtime, and then see if you can meet the demand. And if you can't meet the demand, you're like, okay, let's invest, And you already spend so much money on overtime, all those direct labor costs. So it's just the reality that the whole world is going to have to deal with when it comes to electronics backlog. But if you really have partnerships and you can just work on economies of scale, just buying products at a good price, or components, and looking at storage partners, and I think can really just try to wait it out, and yeah. So that's another, and obviously reduce your risk, because if you want to produce 6 trains a month, and then something that happens is out of your control, it's really gonna delay you, and there's nothing you can really do about that. Yeah. So, and it might be not enough time to now try looking at refurbishing, So yeah, I think those are the 4 technologies I've identified. And I really love the circular economy presentation. It's something that I've actually been looking at. And I was looking from an automotive sector initially, but I just, everything is, from production or from mining to landfill, or you can make it circular. So even from a Gibela perspective, if we're looking at number 1 in the large circle, you've got the OEM suppliers, and OEM part manufacturers. If you actually add that cloud manufacturing implementation framework, now you're moving in a circular economy to number 2, where you're utilizing the facility layout optimization simulation software. I'll just call it, digital twins for process optimization. Huge cost reduction already and capacity increase. And then you've got the global OEM electronics, partnerships, really having a discussion with them and about, how to get competitive pricing, how they can keep stock for you, and, just really negotiating and, forming those relationships. And in terms of application of IoT, product service development, once you're done manufacturing the train, of course, it's not really a wholesale and retail distribution outlet, but if you look at it from that ice cream example I mentioned, now you really get insight into your customer behavior, at a retail outlet where the trains are operating. Then obviously that continues to the end usage. For example, you can have that same application can be now utilized outside of the train. They can even book. You can find out, people pay for the train tickets on Sundays, and they're using it from home. And now we're getting a good sense of the customer behavior around rail, while they're using the app at home. So that's why you can look at it in that point number 4. So any general location at work, etc. So, or they buy in bulk on the 25th. They buy the tickets for the whole month, So you can really get a good sense of customer behavior and, the pains, or do people buy daily? And, then you can start asking questions and analyzing data. And then from number 5, product, end of life cycle disposal. So, I guess this is the same customer experience, tracking to a certain degree. But I really like the head of a South African industrial engineer student chapter. I like your presentation, especially around reintegration into the supply chain. Because if you're looking at our, the whole reintegration of, as I mentioned, refurbishment of electronics, what can we really reintegrate into the Gibela supply chain? That can be, for example, we've got the AIDC knockdown hub project. Why don't we have a Gibela knockdown hub project? And we really try to reuse steel, aluminum, copper, and instead of now spending so much money, we've got so many, or even partnering with the AIDC knockdown hub. They have cars have some of the material that you use in trains, and why aren't we just knocking that down, and reprocessing? We've seen examples in plastics. I think the granular, or the taking a polymer back into a granule and reintegrating into carbon. So that's another framework that we can utilize and try to incorporate it into supply chain reintegration, into Gibela. So, instead of going to product waste and emissions. So, and we obviously, if it's not going to the landfills, we are, playing a role in greenhouse gas emissions, reduction. So those are the ideas that I have, and really excited to have the opportunity to present them here today, and hoping for further discussion, with Rumseri, with Gibela, and all related stakeholders. Thank you.
Thank you very much, Dr. Kulegani, for this beautiful presentation. You are so chilled about it, like you are not advising big people here. Ntate Saka, you are part of Ramsey. I'm talking to you because I don't see Abuti Martin. Is he here? I don't see Martin, I see you. I want to know how you feel before we open questions and comments from everybody in the house. I just want to hear your view. The mic is coming.
Thank you, Madam Speaker. From what I'm seeing here, this is something that I think that we can, some of these things are implementable. For example, like what you said, card system that can be used for multiple things. I think also Reavaya has been using that to buy also at ShopRite. I have a SASA member that I left at home. That one I'm very sure of. So, I mean, most of the stuff that you're talking about, they are implementable. It's just an issue of how do we make it accessible to the township in general. Because when we talk about, when Gibela is talking about railway revitalization, for example, we need to be talking how do we revitalize also the township environment. Martin, when he would have been, here he is, but he would have been using the ABCD approach to say that what are the assets in our areas. The township is losing money because we're not spending money there. So it's one of those things to say that whatever that you're saying, yes, you're talking to Ramseri, you're talking to TUT, you're talking to Gibela, but you need to first go back to the township. Let's revitalize the township environment. David Makura just passed the bill a couple of months ago on the township revitalization. So let's take advantage to that to say that if we encouraging people to use technology, you go to the spaza shop. Spaza shop, here's what needs to be there. Spaza shop owner says yes. Now he can have an EFT system that is there. People that are getting on trains, they're usually buying there by the train station where there are many things there. Already the infrastructure that Gibela is part of is already being used. You understand? All those vendors, when you look at it already, you're uplifting the environment. You're creating that customer base. IoT can be used. Somebody can use their cell phones, for example. Say that there's this vendor. I just type in and then life goes on.
I was not giving you the whole day, Mr. Saka. I just wanted to hear how you feel.
Okay.
I know you are from a Kasi, so don't take it too much to heart. Do you want to respond to that?
Oh yeah, sure. I think those are all great ideas, but I think what our esteemed panel from Gibela mentioned, when it comes to those custom experience solutions, they can really have opportunity for conversations and really exploring, but their priority is 6 rail carts and really scaling up local industrialization. And I think it's really good to explore those conversations and really share ideas. I mean, that's what we're doing here today, And yeah, I think it's something definitely worth to note when the time is right and it's aligned. You hit it straight to the mark, and I think I appreciate what you shared. Yeah.
I really like the point of customer experience. In the morning when they were discussing here, they said, have you been in a train in the last month? According to me, the question was supposed to be, when last were you on a train? And why did you stop using a train? There, I was going to sit down and tell them my story regarding the train and why I stopped. But thank you very much. Do we have other comments, questions?